Yeah, at least part of it. I don't remember if I've split it or not, but all right. So on the AP exam, frequently they'll have problems involving a rate of change of some sort where there's more than one rate going on at the same time. It's not super difficult or anything. It's just something that you need to see. So all the problems we're looking at today, and I think all the problems on your assignment tonight are all straight off of AP exams. So, and you can kind of tell because it's like, you didn't type that, you just copied that.
Do we have a worksheet tonight?
You do. All right. So on a certain workday, the rate in tons per hour at which unprocessed gravel arrives at a gravel processing plant is modeled by G of t equals 90 plus 45 cosine of t squared over 18. So you're getting a certain amount every hour, but it increases and decreases sinusoidally. Notice one thing that I do appreciate about them at the College Board, because they are mathematicians, they use good variables for things. G of t for the amount, for the rate at which gravel is arriving.
What a concept.
Well, you'd be surprised at the number of students when they write things, everything is X and Y. And I'm like, that can be confusing. Okay? Not everything is X and Y. All right, where t is measured in hours and t is between 0 and 8. So that's a work day. At the beginning of the workday, t is equal to 0. The plant has 500 tons of unprocessed gravel. That's another important piece of information. This is how much you have to start with. During the hours of operation, from 0 is less than or equal to t is less than or equal to 8, the plant processes gravel at a constant rate of 100 tons per hour. So there are two different rates going on. Gravel coming in and gravel getting processed. Okay, it's important that you keep track of those. All right, first thing, find g prime of 5. And by the way, these are all calculator problems. Find g prime of 5. Using correct units, interpret your answer in the context of the problem. All right, so we want to find g prime. Since I'm going to use this same equation probably more than once, I'm going to put it in y1 so that I don't have to keep typing that in over and over again. So it'll be cosine of x squared divided by 18. All of you physics fans out there want to make sure that you have done what?
Switch it to radians.
Yeah, make sure that it's in radians.
I learned how to put an equation in y1, like because I was doing percent difference a bunch, and then you just change the variables.
Oh yeah,
Fine.
it is pretty nice. So now I want to do the derivative with respect to x of y1 at 5. So g prime of 5 is going to be equal to negative 24.588. We've talked about this multiple times. Either is fine, but 3 decimal place accuracy is required. So you can either truncate at 3 decimal places or you can round at 3 decimal places.
Why 3 decimal places? Just because
I don't know. All right. So using correct units, interpret your answer in the context of the problem. Okie dokie. So let's look at the original. So on a certain workday, the rate in tons per hour. So this was in tons per hour. And we've taken the derivative of that. So what is this going to be? Tons per hour per hour. There are no square hours. Yeah, and I understand why they use it. It's not wrong, it's just kind of dumb. Yeah. And it would actually make things make a lot more sense if we didn't do that. Right? This is how fast this is changing. So, the rate at which gravel arrives at the gravel processing plant is decreasing at a rate of 24.588 tons per hour per hour. Yes, this also points out a technique, and I had never called it this, but I heard when I was doing my AP stat thing this summer, they call it parroting. When you're asked to describe something in context, use the words that they use. Don't try to paraphrase it, because sometimes when you paraphrase something, you get it wrong. Just quote them. Okay? All right. Part B, find the total amount of unprocessed gravel that arrives at the plant during the hours of operation on this workday. So how can we find out how much gravel comes in? Yes?
We take the integral from 0 to 8 of g of t plus 500.
No.
Not plus 500?
No. Did it ask how much is there? No. It asks the total amount of unprocessed gravel that arrives.
So g of t dt.
Correct. And again, you don't have to write out what g of t is. And since we put it into the calculator, we can just go, okay, math 9 from 0 to 8. Y1 with respect to x. So 825.551 tons. How do I know that that's tons? Well, what were the units of g of t?
Tons per hour.
Tons per hour times dt, which is hours. So that's tons, and that makes sense. Part C. Is the amount of unprocessed gravel at the plant increasing or decreasing at time t is equal to 5 hours? You can't answer this yet.
No.
You got to do some calculations. So Is the amount increasing or decreasing? All right. Well, the amount of gravel we found by taking the integral, right?
Right.
That's the amount that's coming in, but we're also processing this at a constant rate of 100 tons per hour. Okay? So the rate at which the amount is going to be given by the integral, right? Minus how much is being processed. So what we're going to do here is go, okay, we're going to take G of t, which is the rate at which gravel is coming in, right? Minus 100. Because gravel is being processed at 100 tons per hour. So this is gravel in, this is gravel out. That makes sense? That happens a lot on these problems. You have one is going in one direction, one is going in the other direction. Okay, so at 5 hours, that's going to be G of 5 minus 100 is equal to, well, I can figure out what that is. Y of 5 minus 100. I think your calculator will let me do that.
You have to put it in parentheses or it doesn't work.
Yes, because otherwise it thinks you're multiplying. Negative 1.859, which is less than 0, therefore decreasing. So at that point in time, they're processing faster than the stuff is coming in.
Do you not have to account for what they did previously?
No, it's at that time.
Oh.
All right. So then here's the next part. What is the maximum amount of unprocessed gravel at the plant during the hours of operation on this workday? Justify your answer. All right. So the amount of gravel is going to be equal to, oh, what are you starting off with? 500 plus the amount that has come in. So the integral from 0 to x of g of t dt minus 100x.
What's up with the x's?
The x is the number of hours.
Why can't you use t?
Because then I'd be using t both for a variable here and a different variable here. Anytime you have something like this that has variables in it,
Yeah.
that variable needs to be different.
So, will the variables be the same number?
No. So the derivative of unprocessed gravel is going to be equal to g of x minus 100. Right? And I want to find where that's equal to 0. So I want to find where is g of x equal to 100. At this point, I am going to go ahead and graph my y equals. And we notice that it starts at 90, it's going to go up to 135 and go down to 45. So for my window, I want to go from 0 to 8, because that's the time limit. And I'm only going to go, say, negative 10 to a height of 150 or so, so I have plenty of space. And I don't know, I'll scale it by 20. So gravel's coming in at a pretty quick rate at first, but then it slows down. I'm going to graph y equals 100 also, and find where those two intersect. They only intersect once. So calculate the intersection. And it's what, 4.9234. So now I know where the derivative is equal to 0. So now I can use the candidates test. What happens at time t is equal to 0? What happens at time t is equal to 8? And what happens at time t is equal to 4.923? Well, how much gravel is there at time 0?
635 tons.
Nope,
500 tons.
500 tons. At time 8, that's going to be 500 plus the integral from 0 to 8 of the rate at which gravel is coming in, minus 800, right? We're processing 100 tons of gravel every hour for 8 hours. This is 525.551. And now we'll see what happens at 4.923 hours. So that's 500 plus the integral from 0 to 4.923 of my function with respect to x. minus 100 times 4.923. So that's 635.376 tons. There's a lot of good stuff in that problem. Makes you do the candidates test, makes you think about integrals, all that kind of good stuff. All right. Oh, and there are all the answers. And this is the actual rubric that they use to grade this. So if all you were able to do on part A was to give G prime a 5, you got a point. The interpretation with the correct units. So if the units are wrong, you don't get that point. So here we're taking the integral. On part C, I didn't like the way they did that, but that's an acceptable way to do it also. We got that it was negative, right? But you could also compare it to 100. 100 is how fast it's getting processed. Compare that to how fast it's coming in. I also didn't like the way they did this. You can do this as an integral. That makes sense. 100 is the rate at which it's being processed, right? I just did them separately. But either way, it comes out the same. All right, let's look at another one. The rate at which people enter an amusement park on a given day. Make sure that we have plenty of time. Oh yeah. Is modeled by the function E, defined by E of t is equal to 15,600 divided by t squared minus 24t plus 160. The rate at which people leave the same amusement park on the same day is modeled by the function L, and again, E and L. It uses smart letters for these. It doesn't just, I'll call everything X and Y.
Leave the amusement park on the same day? Like some would stay overnight?
No. This is the rate at which they leave.
Oh.
Okay? So you have people coming, people going all the time. Okay? Both E of t and L of t are measured in people per hour, and t is measured in hours after midnight. These functions are both valid for 9 is less than or equal to t is less than or equal to 23, the hours during which the park is open. At t is equal to 9, there are no people in the park. How many people have entered by 5 o'clock? Round your answer to the nearest whole number. Why would you do that?
Because one person.
Yeah, it's the number of people. It makes sense.
Crazy. Half the person coming out.
Well, you can be counting, this much of his body is outside of the, gate at this point. So by 5 p.m., so this is the rate, right? And this is a rate. Notice those are working in opposition to one another. How many people have entered the park? Well, it'll be the integral from 0 to 17 of E of t minus L of t dt.
Didn't you just do the integral from 17 of EFT?
Oh, sorry, this is just entered the park. My fault. I thought I'd ask how many people are in the park. So again, I'm going to put these in Y1 and Y2. So I'm just doing math 9 from 0 to 17. Of that first equation with respect to x. 8,366 people.
Mr. Davis,
Yes.
aren't you supposed to do it from 9 to 17? Because there's a.
Oh, yeah. Thank you. Man, I'm not doing so well on this one. So 6,004 people. So the price of admission to the park is $15 until 5 o'clock p.m., which is T is 17. And it's nice of them to remind you of that. After 5 o'clock, the price of admission to the park is $11. How many dollars are collected from admissions to the park on the given day? Round your answer to the nearest whole number. So that's going to be 15 times, well, we already know how many people have come in, right? At that point. So times 6,004. Plus, we're going to get $11 times the number of people who've come in between times 17 and 23.
There's our guest speaker for chapel.
We have a guest speaker today.
Yeah, Mr. Nelson.
Cool.
How do you feel? Wow. I should make the Texas Instruments calculator with like voice command.
That would be obnoxious.
That ever stopped you before?
No.
So $104,044.
That's a lot of money.
Yeah. Let h of t be the integral from 9 to t of e of x minus L of x dx. Again, notice the variable here cannot match the variable there. For 9 is less than or equal to t is less than or equal to 23. The value of h of 17 to the nearest whole number is 3,725. Find the value of h prime of 17 and explain the meaning of h of 17 and h prime of 17 in the context of the amusement park. All right, well, h prime of 17, let's find h prime of t first. What is h prime of t going to be?
E of t minus L of t.
Yeah, e of t minus L of t. So h prime at 17 is going to be e of 17 minus L of 17. Go away. So e of 17 minus L of 17 So what does the 3,725 tell us?
It tells us
How many people are in the park?
Yes, at what time?
17.
Which is
5.
5 o'clock. So at 5 o'clock p.m., yeah, except they don't in the problem, so you shouldn't either.
But don't they kind of do it? 'Cause hours.
They kind of do, but
But if I'm spontaneously because you're PM,
so at 5 o'clock p.m., there are 3,725 people in the park. Which is changing, or I guess it should say decreasing, at a rate of 380.281 people per hour.
You don't want to make that one a whole number.
Nope, it's a rate. Rates don't need to be whole numbers. All right, and then the last part, at what time t, for t between 9 and 23, does the model predict that the number of people in the park is a maximum? Well, since h of t gives you the number of people in the park, we need to find where the derivative is equal to 0. So we want to know where is e of t minus L of t equals 0. So I'll go back to my calculator. I'm going to go to y equals, and I don't want to type all that, so I'm going to go y1 minus y2. And I'm going to turn the other two off.
how do you do that?
Go over the equal sign and hit enter. And for my window, I'm only concerned from the time between 9 and 23, right? So I'm going to go from 9 to 23, and I'll count those by 1. That's not too many tick marks. And I'm only concerned about when that's equal to 0.
So you can do like -1 to 1.
Yeah, I'm going to do negative 10 to 10 since I already had that in there, but it doesn't matter. So find where that's equal to 0. It's somewhere in the middle, but since I know 9 and 23, I'll make 9 my left bound and 23 my right bound, and 15.2. That's not going to be anywhere close. Oh, that was not bad.
Oh. Dang.
So t is equal to 15.795. So we know that the number of people at time 0 or time, sorry, I keep doing that, time 9, there are no people in the park, right? Makes you wonder how many people are in the park at time 23.
I'm gonna guess 0.
One would hope. Punch it in real quick, but I'm pretty sure it is.
You punch into H of T.
Yeah.
Yeah. So it'd be the integral from 9 to 23 of E of t minus L of t. Maybe there's some stragglers.
There's one person in the park.
There's. Have you seen my mommy?
Would probably be Irfan at that.
And then at 15.795,
You know, someone was writing this textbook and made it so that one person was left.
what does that come out to be?
3,951 if you round it up.
3,951?
You can't divide the person unless there's a lawsuit.
All right, let's take a look at what they say.
Do they
They
count?
agree with me.
But do they count conjoined twins as two people?
Depends. Physically, it's one person. Mentally, it's two people.
Oh, no.
They agree with me.
What did they ask in the last one? Oh, at what time? So be sure to answer the question. It's 15.794, 15.795.
Is this
Yep.
is this a calculator quiz or
No,